Hello and welcome to Algebra. Today we're going to look at our lesson on 7.3. We're going to continue by looking at a few different properties. Again, we have the Xerox it, so a to the m to the n power. It's just going to be a to the m times n. So if you had a to the third to the second, you're just going to make two copies of a to the third. So a to the third times a to the third, that'd be 3 plus another 3 is going to be 6. So basically you're just multiplying them. Sometimes it's easier to think of just making copies, and sometimes it's easier just to go ahead and multiply those out. So it just depends on the situation. Okay, so in this case we have q to the third r all to the fourth power. So this 4, that's the first place my eye is going to go to. Be very, very careful. Some students will try to do, let's say if we had something else here, they'll try to combine something that's in the parentheses before dealing with these exponents up here. Be very careful. That's a really bad idea. You have to deal with these exponents outside of the parentheses before you deal with anything inside. Another thing that we need to think about is an issue of authority. In my classroom, I have authority over my students, but I may not have authority over the classroom next door to me. So you have to think, this 3 has authority over the q, so it's like the 3 has authority over just that q. The 4, though, it's in parentheses. It has authority over the r and over the q to the third. It has authority over both of them. So if you think about that authority, it's like Ms. Z or Dr. Rivers, they have authority over both, but this is like me. I only have authority over my classroom. So you have to think about that. That's going to help us a little bit later down the road. Now we have two options. We can either make Xerox copies, so we can say q to the third r, q to the third r, q to the third r, q to the third r. We can either make 4 exact copies. Very simple, very easy. So that's 3, 6, 9, 12 q's, and 1, 2, 3, 4 r's. Or you can just multiply it. Q to the third to the fourth power, r to the fourth power. If you make 4 copies of 3 of these, that's 3, 6, 9, 12 altogether. So that's q to the 12th, r to the 4th. So you can think of it either way. It doesn't really matter. Now when this number here, this exponent gets a little bit bigger, it's going to be much easier to do this method. If it's a small number, it's probably a little bit higher percentage shot. If you think of basketball, you dunk it versus you taking a 20-footer, it's a lot better percentage shot to go ahead and dunk it. So this is the higher percentage shot if it's a low enough number. So it just depends on the situation. Now we're going to look at some with some decimals. These can be very tricky, so be careful with this. All right. Now notice that we have like bases. The 1 and 34/100ths, that is that base. It is like, they're the same. So I'm going to look through and try to combine as much of this exponent as I can. Now this 5 here, that's the first place my eye is going to go. So look right there. Don't worry about anything else. Well, I guess you could think about this one as well, because when you first look at it, you need to look at any exponent that's just outside of those parentheses. So we have 1 and 34/100ths. Now it says that we're going to do 5 exact copies of that 2. Well, 5 exact copies of 2, 2, 4, 6, 8, 10. There are 10 copies of that 1 and 34/100ths. There are also -8 copies of 1 and 34/100ths. Remember from what we had done earlier, this is a Chuck Norris situation. We're going to make the 2-story house. He's going to get booted down to the bottom. Or another way to think of it is to rack them up. Remember we had like bases. When we have those like bases, you're going to add them up. Remember the cool pool shot. In that pool shot, he got a couple here, a couple there, a couple there, and you just add those up. So 10 plus -8 is going to be 2. And of course you could have that over 1. But that's more of the Chuck Norris situation if you wanted to apply it that way. 1 and 34/100ths, you're just going to multiply 1 and 34/100ths times 1 and 34/100ths. And that's going to give you 1 and 7,956 10,000ths. The other way would be to go across here and Chuck Norris. This is something we're going to be learning in the next lesson. When you boot it down, he's positive now. Basically, you have 10 1 3400ths on top. You have 8 1 3400ths on the bottom. Anything divided by itself is 1, so 8 sets of these divide to 1. There's 2 left over on the top, so you can go sort of a little detour here, and you'll still come up with the same answer. That is actually the lesson we're going to work on next, in our next lesson in 7-4. Alright, one more problem. Okay, so this is a little more complicated, but it doesn't have the decimals, which is good. So the first place I look is this 5 and this -7. So we're going to Xerox it, just make copies of. Now you notice 5, 7, it's going to be difficult to make that many copies straight across, so we're just going to distribute this across. So this is going to be 12 to the 5th. So now you're going to distribute this onto each. 12 to the 5th, x squared to the 5th, y to the -2nd to the 5th, and of course all this is times 4 to the -7th times x to the -7th times y to the -3rd to the -7th. Do you have to do this step? No, this is optional. You can go straight to this one. 12 to the 5th, x to the 10th, y, let's see, -2 times 5 is going to be -10. 4 to the -7th, we'll deal with that negative in just a minute, and this negative. X to the -7th, y to, well, see, -3 times -7, positive 21. So now we have all of this. It is a lot of stuff going on there. Let's just rearrange it a little. 12 to the 5th times, I'm going to put all of the integer bases out front. Then I'm going to put the x's. And now I'm going to put the y's. And now we're going to continue. We're going to combine these x's together. Remember, we rack them up. So 10, and then we have -7. How do we have -7 pool balls? I have no idea. But 10 plus -7 is going to be 3. Y to the -10th, y to the 21st power. That's going to add up to give me 11. And then we have these two, 12 to the 5th times 4 to the -7th. So now I'm going to make this, we're going to talk about the Chuck Norris with that -7, sort of make it a 2-story house, just like the little picture. And Chuck Norris does not like this because he's being negative to his girl. That's not going to cut it. 12 to the 5th, x to the 3rd, y to the 11th, over 4 to the 7th. Now, anything we can do, we need to do. That's sort of the idea of simplifying. Any zero exponents you need to do, any of these exponent outside of parentheses we need to do. If there's a negative exponent, we need to do that. Anything that we can possibly do, we must do. If you had like 4 in the top of the numerator and 6 in the bottom, 4, 6 would be 2/3. Anything you can do like that, you go ahead and do. Now, 12 to the 5th, I can do that. X to the 3rd, there's nothing much I can do with that, so we're just going to leave that alone. 12 to the 5th, go ahead, multiply that out. And I know it's ridiculous, but you're going to get 248,832 x to the 3rd, y to the 11th, over, and then 4 to the 7th, 16,384. So you're just going to reduce this down. Now, if you don't have a calculator, divide by 2, divided by 2, keep doing that, divide by 3, just reduce it as much as you possibly can. Now, part of the Common Core standards are that you should use tools appropriately. Well, this is a perfect time that you should use a calculator. Probably the best way that you can use a calculator, if you have a TI-84 Plus, do alpha, the green button, and y equals, and it'll pull up a fraction menu. So once you pull up that fraction menu, you put 248,832 in the numerator, 16,384 in the denominator, and that way you're going to have, you can go ahead and hit enter, and it will reduce that fraction for you. And we're going to end up with 243 x to the 3rd, y to the 11th over 16, and that pretty much does it. Thank you so much, and have a great day.